In this video, I'm going to talk a little bit about what's going on here, a part of the experiment. So you can see here, students are putting in 200 milliliters of water into a beaker full of peas and an eighth teaspoon of salt. Students are putting it in a blender. Direction state to blend the mixture of peas and water and salt for about a total of 15 seconds. So 15 seconds is what is needed to actually be able to disrupt the peas and actually be able to break the cells apart in order to begin the DNA extraction process. After the 15 seconds, the directions state to pour the mixture into a beaker using a strainer. As you can see, my student had a little bit of difficulty in removing the top portion of the blender. I guess not familiar with, but their teacher comes to the rescue. So in this particular, what students are directed is to use a strainer and pour the solution into another container, a measuring cup, or in this case I just use another beaker. It's important for students to measure the amount of time of dripping because it will overflow due to the thickness of the blended mixture. So students are just directed to, as the liquid goes through the strainer, little by little, going ahead and placing more of the solution into the strainer. This works well with partners, obviously, to be able to do it. In this particular case, the next part of the directions is to get any type of soap. You need about 30 milliliters, so I just use some regular unscented clear dish soap. You're also able to use different types of detergents. And what you need to do is you go ahead and place it in the solution that was strained. I went ahead and fast forwarded. It does take a while to strain all the solution. And the directions say to pour all of the 3 milliliters of soap and mix evenly. I would say about 10 seconds. With a spoon, mixing the solution pretty well to get everything really blended and really well. So you can see my student blends the soap solution pretty well. The directions then state to once blended to leave it for about 5 to 10 minutes to let it settle. So you can see it fast forward the 5 to 10 minutes, and then the last portion is you go ahead and you pour about a third of a test tube with the solution, making sure it's just a third and not all the way to the top because you're gonna need something else. Um, and here's my other helper. Same thing with a third of the solution. And finally, the last part of the lesson, actually, I'm sorry, is putting some meat tenderizer. It's an enzyme. The meat tenderizer is an enzyme, so a little bit, just a sprinkle of it, making sure to use a straw and gently, definitely gently mix this solution, this combination, not too violently, or it can really disturb the DNA that will result after the next step. So students gently with a straw mix the solution with a sprinkle of the meat tenderizer. Directions do state that the reason for the meat tenderizer is to use an enzyme to speed up the process. Finally, the last portion of it, students use some isopropyl alcohol. Directions say at least 90%. Making sure that students tilt their test tube, pour, and it should be about an equal amount in terms of volume of what the green solution was. This will pretty much immediately begin the clumping process, and you start seeing some of the DNA rise and pretty much settle in the top portion of where the alcohol and the water meet. You'll see a clump. So I'm going to go ahead and show the final product here at the end. This is about maybe about 9 to 10 minutes after this. You see that clump right there, and that would actually be the final DNA process. Well, hopefully that'll help you visualize the directions of how to extract DNA from everything. Thank you.